Hey, it's Connor Steele, and I'm going to walk you through some changes that have happened to our game lately. So, I'll just jump right into the action. We have a new sprite, and this is tied to some issues that I was having with our old sprite. Right now we don't have animations, but we do have the move up and move down animation from the old sprite still in, so ignore that for now. I'm just going to go ahead and get to the main point here of one of the things that we've implemented during the 3-day weekend that just happened from February 15th to 17th. So if I go ahead and jump in here, my turn will start, and I can move around. And then as soon as my AP hits max, my turn will be over and the slime can go. And when the slime hits me, his turn's over, but he does damage to me. So it's pretty similar to what we had in our blueprint version so far. However, we can jump in here, and all the slimes are now aggroed on us. But I did notice that there's an issue where the game's basically stuck right now because this slime cannot hit my collision box. So we need a way to move these slimes out of the way or get this slime in here from around. The pathing needs to get improved basically because we're just using a straight up move to this one to this one right now. Let me just find that. Enemy slime, move to. It might just be in the enemy class right now. Oh, I know exactly where it is. So, it is in... We just did this part in Blueprint because it's actually easier to do the stuff for this in Blueprint, this whole AI move to system. There's potential that we could re-implement in C++. Chris actually might have had it working, but we had another bug that was we didn't super call begin play, and it was making tick not even work. So that was a pretty big problem. So well, I'll just show this happening. I'll stop. I'll play again. So I'll get down into battle with one of these bad boys. I'll move out of his way. Move pretty far away, and then he'll come and get me because it's his turn. So yeah, this whole system works a lot better than our old system. I'll pull up the code for this now. Let me think about where we put this. I'll just look at the player one right now. So each character has a cone that tells them what they can see, and that's called the vision sphere. So basically, when another enemy player enters your vision sphere and you haven't started battle already, you will start battle. And you will get added to... You'll get added to this T array right here of battle cares. So battle cares is empty by default. It'll dynamically resize when we do this add to battle function. Let me go to the implementation of that. So here's the add to the battle system right here. And it's using the struct that we created. We might need to store the battle index, we might not. Forget about that for now. And even this class name thing. Yeah, really the only thing that we need is this character ref. So we might not even need a struct, but if we want to store other data, we can. This is the most important part. We can use this. And we have a bunch of inherited classes now. We're using Polymorphism to do a lot of the hard work that we would need to manually do otherwise. It makes it way, way easier than what we were going to have to do if we didn't implement it this way. This is just the way it should have been done from the get-go. So we have our base 2D character right here. Let me pull up the header file for that. Here's the header for it. Everything, the code's pretty messy. We'll clean it up, but there's a bunch of booleans. One thing that we noticed was things in the constructor, sometimes if you set them there and then you want to change them, they will not change at all. And it makes you feel insane because you change something and it really should update on the game side, but it doesn't. And you just... all the like tutorials and stuff are telling you to do this, and it just didn't work. Let me pull up an example of this. The Protag class has definitely happened. Alright, so these booleans are one of the things that we had to move down here because setting this up in the constructor just gave behavior that was not right. So I honestly am not sure why that change had to happen. Everybody that I was looking at put this stuff in the constructor, but we're not going to do it that way because it just doesn't work for us when we try to make it. It just won't update in game. And I've rebuilt the solution and whatnot after putting the constructor, but that really shouldn't have to happen in the first place. So down here it works if you just press compile. Oh, that works. And this is another part. The functions here would get bound in the constructor, and then when you compile and then you try to like change the function or maybe call like a different function, it wouldn't work. So we removed them from the constructor after a lot of trying to fix it other ways and put it down here, and Chris found this remove dynamic thing, and now this works perfect. It works exactly how it should. Before it was really infuriating. So put this in begin, play, all these dynamics. Because in the constructor we just did not have. Maybe if you have just the remove dynamic in the constructor, that'll work, but I'm just don't want to mess with it. I'm just going to leave them here for now because I know 100% for a fact it's going to work. Maybe there's some issues that you don't want to put these here, but I can't tell anything for right now, so we're going to roll with it. So, although the character and the enemy slime both get added right here, it has the same function as the protag class, almost identical. Let me just move this. Okay. Sorry, I got a little distracted there. Okay, so this one, if the other actor is enemy class, this will be null if the cast fails. And the component is the capsule component, so this is like the root component of the enemy blueprint or class. And then you're also not in battle already. What you want to do is you want to say that you are in battle now, get the game mode, and then call that add to battle. This stuff can probably be changed, so honestly you can probably just pass a reference to this. It'll print player adds to battle, and then the game mode ref will go to the next fighter, because now there's one thing in the array. If we go over to the right here, if active fighter, this is a check, out of bounds check to see if you need to loop back around on the array. Otherwise, you cast the active fighter as a base 2D character, and then you start their turn. So this is the functions. If I go to the base 2D character, are set up as virtual voids, virtual void start and end turn, and that means that they can be they're polymorphic functions. They can be overridden. So when they're called from here, even though it's a base 2D character, it's going to call whatever the right class is. So if an enemy slime is stored in the array as a base 2D character, when start turn gets called, it's actually going to go ahead and call the enemy slime's start turn. And then when the player in the array comes up and it calls start turn on the player, it will call the right function. And this is a really big advantage of setting the system up this way. We can just iterate through the array this way and call the same functions on everybody, but they all have their own logic to handle it on their side. Let me just scroll around to find out. Oh, it's right here. You can see the player characters, one right here, and then they both have an end turn. So that whole system works way better than anything that we had implemented before. Big plus moving to see the C++ version versus the Blueprint version. Sure, we could have implemented a system in the Blueprint version that would be comparable, but this was pretty easy to understand given our background in computer science. So there's more stuff that got changed. If you press Shift E, the game will rotate, and you press Shift Q, the game will rotate the other way. And you'll notice that as we move around, the enemy will continue to face the camera. It might look like it's facing the player character, but we actually had that issue earlier. These enemies are going to face the position of the camera. And this is a big deal for us because that allows us to rotate the game. Originally, thought we were going to have no rotation, but then I noticed that there are issues with camera clipping. The way we have the camera set up right now, it can clip through geometry if you get in a bad angle. Because otherwise the camera will get up. Right here, you can see we're clipping through the geometry, so you can just rotate the camera to fix that problem. The alternative is to make the camera get really close to the player, and it kind of makes it really hard to see. So I think just giving the player the control of the camera was the way to go on that one, so they didn't have that problem. So the way that this works for the sprites always facing, these aren't implemented with it, but if I walk over here, you'll see that this version, he will always face. And we have lighting now on our sprites again. They're just using the default list, the texture, the default material. If you go View, Show Engine, Show Plugin Content, and then down to Paper 2D Content, I am using the default lit sprite material or the mask lit sprite material. So let me show you that if we rotate away from the sun, we get dark. And as this person rotates away from the sun, they get much darker, just from the lighting that they receive on their character. And here is an example of the character sprite blown up to a much larger scale. And if we rotate, you can see that this side's dark. So the way that the sprites always face the camera is done in the highest level class, because we always want it to happen. And it's happening in the tick event. We get the camera location in the world, and we get the component location in the world, and we make a rotation matrix on the y-axis only, and then we make a rotator out of it, and then we get the relative rotation of the sprite, and we use the original pitch and roll of the sprite, but we want to update the yaw with the new yaw that we're getting, so we're setting the relative rotation there. And then we have, if we don't do this right here, we actually won't face the camera. We'll be like parallel to the camera. Let me show you. I'm just going to move these slimes up off the ground because they are clipping through it. Okay, so that's compiled. So now you can see that if we don't add the 90 degrees, they are facing parallel to the camera. And yeah, that's a problem. So let's go ahead, add that relative rotation back in. And you want to do things like this because it's updating, it's doing more math than you might think it would be doing, because me and Chris had to monkey around with this for quite some time, and then after we split it up more, we got it working the way we wanted it to. So let me just sorry, I just have too many windows open right now. I'm going to compile this and jump back into the game. Okay, we're back in. So now you can see everything faces the camera again. So one of the reasons I switched to these sprites is because on this sprite, I thought I was having like more issues with Unreal, and I was getting pretty scared. But if you move on this sprite, you can see that the textures actually, or the sprite has problems on the edges. The hard edges are not, they're not hard edges, they're pretty bad. And when this is in motion, downscaled, it does not look good. But before I even thought that was an issue, I thought it was an issue with Unreal. So I did some research, and I actually did find that this Ludicrous Games right here, they have a bunch of really good articles about working in Unreal with pixel graphics. So The scaling thing right here was pretty important. I changed all ours to use integer scaling only because we do not want this. It looks much worse than either of those. Our slime sprites need to be updated. They are a little blurry just because of the way that I packed them into the texture sheet. I can change that. I figured out how to change it, and it'll be nice. But that was basically the thing. There's also ways to snap the camera, so you make sure that the camera is pixel perfect right here. So everything should be aligned to the pixel grid. All these really good tips. Prevent jittering. Sprites shouldn't rotate. And this one scared me because our sprites do rotate constantly. But I think a lot of the principles that this person is talking about may not hold as true right now for us because we're actually doing a 3D game and they're doing a straight up full-on 2D game where I would assume that they're using an orthographic camera and we're using a perspective camera. But I think it's important to know these things in case it does end up being an issue. We have somewhere that we can jump to right away to know what's going on. This is concerning to me just because of the way that our sprites rotate. But even if I'm going to zoom the camera way in on the player character right now. Let me just save everything before I do this so I can revert to exactly what it was. I zoomed the camera out too and changed some scaling stuff, but let's just say negative like 100 and then like 10. Let's compile and save this. Okay, we're really close now. I think that the textures, they look pretty fine, I think. Like I said, the slimes, they have an issue with the way that I pack the texture, the sprite sheet. So I think I can fix that. But if I run over to this player character, as they rotate, I do notice somewhat of a lack of hard edges. I mean, it looks pretty damn clean to me, and I think it's probably good. I'm just trying to get as close as I can to see on the rotation. I think it looks pretty good, actually, for just using the default material. We can set up our own materials, too, and whatnot, but I think it looks fine. But definitely with these ones, I just do not use. You can zoom in on... Oops. Let me just zoom in to exemplify. Look at this. These are not hard edges. Looks... In motion, it looks really... not weird. It looks bad. I was focusing on it more lately, but if we pull up an example of, like, you know, ours, we're almost as zoomed in as those are hard edges. That's what we want. Much cleaner graphically. And I just pulled this sprite sheet from online, some random Google search, so it makes sense. These sprites are also actually not like tiny, like pixel art. These are pretty big files. And these ones are like 50 by 50 or less. So this is actually very, very small artwork. Okay, I think I covered most of the things I want to talk about in this video. I did think that we were having a bug that I wanted to talk about, but... wrong game. I'm going to port over some of the other stuff. I will work on the animations, and we just need to get some more battle stuff figured out. But honestly, I think that the game's coming together really good now that this is all working out. I was really concerned about that sprite thing. I was concerned it was going to take a really long time to figure out, but I'll make an animated walking motion for this sprite so we can get that figured out right away. Thanks for your time, guys. Sorry for rambling for longer than I intended to. Have a good day.